6.2 is going to give us another skill to use in factoring, and it's a different kind of skill. What we have so far is greatest common factor. It is used for all polynomials. You always start and ask yourself the question, can I find and factor out the greatest common factor? Then, if you have 4 terms, you're going to use grouping. And we have done that as well. This section is about polynomials that have 3 terms, and I'll refer to them as trinomials. We will use a method called trial and error. Some teachers call it guess and check. And there are teachers that teach this by something called the box method. I don't use the box method. I don't mind if you know it from some previous experience and you want to use it, that's fine. But I don't teach it. Somebody in my first class says, oh, then that means you think outside the box? I was like, yeah, I'll say that. Yes, that's why I don't do it that way. It actually just doesn't appeal to me, okay? Maybe I'm right, maybe I'm wrong, but it's mine. All right. Let me go back where I've got some blank space. Before we can work on this method, I need to review some multiplication. Do you remember that when we did greatest common factor, I reviewed distributive property? And then finding the GCF and taking it out is reversing that. Well, trial and error reverses FOIL. So I need to review FOIL. All right, I'm going to do 4 review problems. There are certain things that I hope we observe. Let's multiply x plus 2 times x plus 5. And let's use FOIL. What's the product of the first? X squared. Right. X times x gives us x squared. Now I need to look at the outer product, which is 5x, and the inner product, 2x. Add those together for 7x. So in this teeny tiny little writing, I have the outer product of 5x and the inner product of 2x. What's the product of the last? 7. Multiply? 10. 10, okay. Now, that's my answer, and our job in section 6.2 is going to be to start with the trinomial and try to rediscover the factors. Now, no, we're going to come up with a really, really solid way to do it. At first, you might think, oh my goodness, how am I ever going to figure that out? We're going to see patterns and be able to do this. One of the things we'll look at in a minute will be the signs. But let's go ahead and get our second example so that we can then compare some things. All right, let's look at x minus 2 times x minus 2. I'm sorry, minus 5. So similar to my first example, but I have intentionally made both of these negatives. What's the product of the first? I have x squared. The outer product is negative 5x. The inner product is negative 2x. And when I add a negative to a negative, I get negative 7x. Because when you add negatives, it stays negative. Then when I multiply negative 2 times negative 5, I get plus 10. Now I'd like you to take a moment to compare these. These are very, very similar answers, and the only difference has to do with the sign of the middle term. Whether you were multiplying a positive times a positive, you got the positive 10, or a negative times a negative, you got the positive 10. So what we might conclude is when the last term is positive, that the 2 signs in the factors are totally determined by this middle sign. When the last sign is positive, the 2 signs in the factors are totally determined by this middle sign. When the last sign is negative, the 2 signs in the factors are totally determined by this middle sign. When the last sign is positive, the 2 signs in the factors are totally determined by this middle sign. When the last sign is positive, the signs up here always match the middle one. Something else to notice. You have a 10. Does everybody agree that the last times the last got us the 10? But that the outers plus the inners gave us the 7. So what I hope you notice is 2 times 5 gave you 10, but 2 plus 5 gave you 7. Down here, -2 times -5 gave us positive 10, but -2x and -5x gave us -7x. So when I start with this trinomial, I'm going to be looking for numbers to go in here that have a product of 10, but a sum of 5. I'm sorry, I just said that wrong, but a sum of 7. Okay, so just kind of put that in the back of your mind, and let's look at 2 more multiplication problems. Let's suppose I have x minus 2 times x plus 5. This time I have 1 positive and 1 negative. Whoops, I always do that. There we go. What's the product of the first? X squared. The outer product is positive 5x, but the inner product is negative 2x. Because the outers and inners have different signs, when I say I'm going to add those, I really end up subtracting them and keeping the sign of the bigger one. So I'm going to have plus 3x. Then what's the product of the last? It's going to be negative 10. So I did something a little different there. Because one of my outer was positive and my inner was negative, I ended up taking the difference. Last example, and we'll use this for comparison, x plus 2 times x minus 5. What's the product of the first? X to the second. Now this time the outer product is negative 5x, and the inner product is positive 2x. They still have different signs. It will be negative 3x for that middle term. And what's the last one? It'll be negative 10 because I have a positive times a negative. All right, now look at these two. Look at these 2 problems. When I have a 1 plus and 1 minus, 1 plus and 1 minus, I do the same things in that my inners and outers have opposite signs and I subtract. But in one of these, I got a positive middle term, and in one of them, I got a negative middle term. It had to do with whether the big number or the little number was attached to what sign. When the last sign of the polynomial is a negative, you always get 1 plus and 1 minus. And then we'll worry about, well, what number do I put in which one? Okay, I want you to take a look at a sheet that, if you look at the video, it's in there. It is also in the handouts button. If you went to my math lab and you went to the button that says handouts, this is one of the handouts. It says sign patterns for factoring trinomials. And let me enlarge it for those of you who are here. Okay. If you have like x squared plus 5x plus 6, something like that. If the last sign is positive, and down here the last sign is positive, then the signs of the factors are always determined by the middle term. Okay, so both pluses in this case, both minuses in this case. If the last sign in a trinomial is negative, it doesn't matter what the middle one is. They're always going to be 1 plus, 1 minus, 1 plus, 1 minus. So if the last sign is negative, you always get 1 with a plus and 1 with a minus. Now the middle term will tell us where to put the big factor, but we'll look at that in a minute. So if you'd like to have your own copy of those sign patterns, they're under the button of MathLab that says handouts. So I'm going to go to the 6.2 problems, and I think I'll do what I did last time, which is write them on the notebook paper part. So problem number 1. It says to factor x squared plus 15x plus 56. Okay. When I ask you to factor something, the first thing you should do is look at all the terms and ask yourself, is there a common factor? Well, x isn't in the last one, so the answer turns out to be no. All right? So the next thing I do is count terms. 1, 2, 3. If there are 3, we will go to trial and error, which means I think I'm going to undo the FOIL. Once I've written my parentheses down, and this is just me, I immediately determine the signs because I understand the sign patterns. If the last sign is positive, then both signs are determined by the middle term. So when the last one is positive, both the signs have to be this. So plus and plus. If the last sign is positive, but this middle one is a negative, then they're both negatives. Okay. Now, you have to be thinking about FOIL. To get an x squared, what would have to be in the first positions? X. X times x. So that part's easy. Now, to get a 56, this first position, I'm sorry, I shouldn't call it a first. The last position here times the last position here have to multiply together to give us 56. But there's more to think about, because not only do they have to multiply to give you 56, but the inners and outers have to add up to be 15. So there's 2 things to happen. Blank times blank has to be 56, but blank plus blank have to add up to be 15. Now, some of you have already gotten the factors in your head, but I want to show you a method in case you didn't. Start with 1 times the number. 1 times 56 would give me 56. But if I had a 1 here and a 56 here, I would have 1x and 56x, and those would not add up to be 15. So that's not right. So then I go on and say, well, will 2 go into 56? Yes. It's 2 times 28. Is the sum of 2 plus 28 15? No. So it's not that. Does 3 go into 56? And the answer is no. Does 4 go into 56? Yes. It goes in there 14 times. And you might have to divide that out to find out. Is 4 plus 14 equal to 15? No, then they're not right. All right, does 5 go into it? No. Does 6? No. 7? Yes. 7 times 8. Is 7 plus 8 equal to 15? Then those are your factors. And I actually heard 7 and 8 from somebody before I wrote down anything, and that's great. That means you don't have to make a list. But you can make the list and simply eliminate those things that don't work. These factors have to multiply to give you the last number. They have to add to give you the middle number. And 7 and 8 work.
And that's all you do?
That's all you have to do, but I strongly encourage you to check it. The product of the first, x times x, is x squared. The outer product is 8x. The inner product is 7x. Those do add up to be 15x. And positive 7 times positive 8 does give me 56. I know I'm right. I have the factors of this trinomial. You may not need to make this list. Then again, you may. I don't know. Number 2, I will make the list. So some of you will just need to be patient with me while I make it. All right, I have x squared minus 9x plus 18. If it says factor, I look at all 3 terms and say, is there a common factor? And the answer is no. I count 1, 2, 3, and I say, okay, that's a trial and error. Put my 2 sets of parentheses. If there had been 4, I would have gone on the path for grouping. Okay, the signs. I do signs first. If the last sign is positive, then we know that both signs have to match the middle term. So it has to be minus and minus. What times what gives me x squared? And we know it's x. All right. Now, this is where the thinking comes in. I have to get last position times last position has to multiply together to give me positive 18. Okay? So, is it 1 times 18? Well, it is if 1 plus 18 is 9. No. All right, 2 goes in there. 2 times 9. Is 2 plus 9 equal to 9? No. It's not that one. 3. 3 times 6. Is 3 plus 6 equal to 9? Yes. I'll put in my 3 and I'll put in my 6. Did it matter where I put the 3 and where I put the 6? No. Because either way, I'm going to get a negative and a negative. They add up to be negative 9x. Really, what I usually just check is that middle term. All right, let's look at number 3. And the way you get good at this is by practicing it a lot. X squared minus 10x plus 25. Is there a common factor? Nope. So it's a trinomial, so I'll go with trial and error. Signs. If the last one's positive, then both signs have to match this middle term. And I've already heard y'all say that means put 2 negatives. I know I need an x and an x. I need factors of 25 that add up to be 10. 5 and 5. Y'all didn't seem to need me to do the listing. I could have. It would have been 1 and 25. No, those don't have a sum of 10. 5 and 5, yes, those do. So sometimes you don't need to write down all the combinations. Let me mention one thing. Oh, by the way, I should check this. That's negative 5x. That's negative 5x. They add up to be negative 10x. It makes me check my signs as well. When you take, if you take intermediate algebra, and you will go on and look at sections 6.3 and perhaps 6.4, the thing that's different is that the leading coefficient will not be a 1. What if this first number had been a 12? Then I couldn't just say it's x and x, and I would have had a whole new issue. Well, is it 12x and 1x? Or is it 6x and 2x? Or is it 3x and 4x? And then I'd have to worry about this, and I'd have to really concentrate on my outers and inners. And so it's not as bad as it might sound, but it is a little more difficult than what we're doing. But we get to start with plain old x squared. Thank goodness for small favors. All right, let's look at x squared plus x minus 20. All right, there's no common factor. It's a trinomial, so I go to trial and error. The reason I say that every time is that when it comes time to take a test, you're going to look at a problem, and the first thing you're going to say, I hope, is there a common factor? If there is, fine. If there's not, fine. Either way. After that, though, count the terms. 4 terms, look at grouping. 3 terms, look at trial and error. Okay, signs. If trial and error, that's what I do first. The last sign is negative. So if the last sign is negative, well, I keep trying to make that be a red arrow, and it doesn't want to be. Okay, it's sort of a red arrow. If the last sign is negative, then I don't worry anymore. I know one is plus and one is minus, because this position times this position have to multiply to be a negative 20. The only way I can get a negative product is if one is plus and one is minus.
So it just stays the same?
Yes, always. Well, and it didn't matter. If that's a minus, you still get plus and minus. If the last sign is negative, you always get one plus and one minus. And it doesn't matter about the order, but I tend to always put the plus first. Okay? x and x. Here's what is different when you've got a plus and a minus as opposed to the first three problems. Your outer product is going to be negative. Your inner product is going to be positive. When you combine a positive and a negative, what do? Subtract and keep the sign of the larger. So I have to think about that when I'm writing down my factors. I'm not looking for two numbers which add up to be 1. I'm looking for two numbers that have a difference of 1. Okay, so let's look. Factors of 20. 1 and 20. The difference of 1 and 20 is 19, so that's not right. 2 times 10. No, because the difference of 2 and 10 is 8, so that's not right. How about 4 and 5? Does that have a difference of 1? Yes. Now, does it matter where you put the numbers? The answer is yes, because there are different signs involved. You want the difference to be a positive 1. That means the bigger number has to be the positive. So pick the 5, and it gets to be the positive, and the 4 gets to be the negative. And then check it. Outer product, negative 4x. Inner product, 5x. Do those combine together to be a positive 1x? Yes. I personally think it's a little more challenging when that last sign is negative. You have a little bit more to think about. Let's look at number 5. Let's suppose I have x squared plus 28x plus 3, and I ask you to factor that. All right, is there a common factor?
No.
It's a trinomial, so here we go with trial and error. The last sign is positive. What does that tell you to do? Both positive. And what was the determiner? Was this guy right here. Okay, what about here? First positions, x and x. What about in the other positions? Do you agree that I have to find two numbers that multiply together to give me 3, and they need to add up to give me 28? Well, is it 1 times 3?
No.
Is there another choice? I mean, 3 times 1, but that wouldn't change anything. If that doesn't work, there is no way to factor this. When that happens, it is prime. And MathLab will say use letter P to designate prime. Pardon me? Well, actually, there's a couple of things that are prime. Yes, the number 3 is prime, but even if it had not been a prime, maybe it had been 4. Well, 1 times 4 and 2 times 2, there'd still be no way to get 28. So when there are no factors that multiply together to make this happen, that's what you're calling prime. So there were really two prime things here. He noticed that 3 is a prime number, and we just showed that the trinomial was a prime polynomial. Can't be factored.
Could you just say, if you're trying to like divide into a prime number from the start, that's when you know immediately?
Not immediately, because let me just make up one, because you bring up a real good point. What if I had x squared plus 4x plus 3? And I ask you to factor that. It's not one of your MathLab questions. Now in this one, no common factor, trinomial, here I go, both signs are plus, x and x. All right, now the only way to get a 3 is with 1 times 3. And they do add together to give me 4. So the fact that that was a prime, that wasn't a killer. It was because they did add up to be 4. But up here, they did not add up to be 28. Okay? So y'all brought up good points about the prime numbers. Let's look at number 6.
I have a question.
Yes.
On all the previous ones, though, like your last number was larger than the middle number.
Uh-huh.
So if it's not set up like that, could that be telling us that it was prime?
It's more likely that it's prime.
Okay.
If the last number, but watch out for things like signs and all kinds of stuff. That is a real strong indicator that prime is a possibility. Is the fact if the middle number is a whole lot bigger than the last number, as long as that first one was a plain old x squared.
Okay.
Okay? It's not a given, but it's a strong indicator. Okay, problem number 6. I have x squared plus 17xy plus 72y squared. Hopefully you notice that in this problem, not only do I have x's, but I also have some y's. That doesn't make the problem harder. It does tell you that you're going to have to be a little more careful about a detail. There's no common factor to all of them. It's a trinomial, so here we go with trial and error. All right, tell me about the signs. Both of them positive. The rule is if the last sign is positive, all signs are determined by the middle sign. I know that I need an x and an x. But what I have to notice in this problem is that if this position times this position gives me 72y squared, then I'm going to have y's attached to my numbers. And now I don't have to worry about them anymore. It also shows me the outer product will have an xy, the inner product will have an xy, and the middle term had an xy, so that's good. I'm good with my letters. Now, I think we might agree that I need to find two numbers that multiply together to give me 72 and add together to be 17. So I need a little space to think about that. All right, 1 times 72 definitely won't work because those don't add up to be 17. 2 goes into 72 36 times, but those don't add up. 3 goes in there 24 times. Those don't add up. 4 goes in there 18 times. And I'm sorry, those of you looking in the classroom, that's gotten hard to read. Still not adding up to 17. 5 doesn't go into it. 6 goes into it 12 times, but 6 plus 12 is 18. No. 7, no. 8, yes. 8 times 9, and sure enough, 8 plus 9 is 17. Now, how many of you in class actually had thought about the 8 and 9 much earlier? Okay, and if you did, then that's great. You don't need to write a list. If the right factors pop into your head, then hooray. But if they don't, start saying 1 times what, 2 times what, 3 times what, until you find the right combination. Now, you would miss, in Math Lab, it would totally count it wrong if you didn't have the y's. On your test, I would probably count off a point because I know that that is an easy mistake to make. It doesn't mean you don't understand what's going on. But you should check it. The outer product is 9xy and the inner product is 8xy, and those add up to be 17xy. So don't forget your variables.
On the test, are we going to have to do the checking too?
No. I recommend some checking, but not for credit. All right, let's look at number 7. What if I have a to the 4th minus 4a squared minus 21? Still not a common factor, but it is a trinomial, so I will go with my trial and error. Even though things look a little different in this problem, the last sign is negative.
Negative and positive.
Right. The rule is when the last sign is negative, you always get 1 plus and 1 minus, no matter what.
Does it matter which side?
Not at all. I personally, you'll always see me put the plus, then the minus. That's just me.
Is it a squared?
Yes, it is. To get an a to the 4th, if blank times blank is a to the 4th, it is a to the 2nd times a to the 2nd. Because the product rule says add the exponents. Okay? Now, I have to multiply two things together to give me 21, and I have to think about this because my outer product will be negative, my inner product will be positive, so I'll be looking for a difference. So, a product of 21, a difference of 4. Is it 1 times 21?
No.
Is it 3 times 7? Yes, those have a difference of 4. Now, which one goes where? The larger number has to go with the sign of the middle term. And if you put them in the wrong spots, hopefully you'll check it and find that out. That gives me negative 7a squared, positive 3a squared, subtract, keeping the sign of the big one, gives me negative 4a squared. Number 8. I have 18 plus 19m plus m squared. Now, I chose to do this one, and you'll find your number 8 to be similar. I don't know about you, but this trinomial looks backwards to me. Because not only do we like our leading terms to be positive, we like them to be the big power, descending order. So I'm going to rewrite this as m squared plus 19m plus 18. It can be factored in the order it's written. It's unusual if you do that, and I think Math Lab might even get mad about it. So we'll reorganize it. We notice there's no common factor. It's a trinomial, so I get my parentheses ready. Tell me about the signs.
Positive, m.
Both positive. I need m's in the first spots. I need factors of 18 that add up to be 19. How about 1 and 18? I don't need to go any further. Those add up to be 19. And it doesn't matter which one you put where because they're both positive. The outer product is 18m and the inner product is 1m. That gives me the middle term of 19m.
Now, why did you rearrange it?
I rearranged it because I would really like the first term to be the high power. Okay? All right, let's look. We're going to skip to number 10. I have 5x to the third minus 25x squared plus 30x. Now, I don't have a lot of examples of this, but it is important for you to note. Every single problem where I've said factor, I've started out and said, is there a common factor? Or sometimes I got real lazy and said, there's not a common factor. But look at this. There is a common factor. So, all right, 5 is in all of these, and the low power is the common x. So I will go back in my mind to lesson 6.1. The first thing we learned. Divide this by 5x, divide this by 5x, and divide this by 5x. The 5's divide out, and I get x squared. 5 goes into 25, it'll be minus 5x. 5 goes into 30 6 times, and the x's divide out. And so I now have 5x parentheses x squared minus 5x plus 6. That's not quite the answer. If we were in lesson 6.1 and that was the limit of what we knew how to do, greatest common factor, we would assume we had done everything possible. But we know about factoring some trinomials now. So I'm hopeful that I can factor this further. Now, something that's important is to bring down that common factor. It is a factor even if I ignore it from now on. All right, I'm about to ignore it. I am not looking at 5x anymore. He's not playing a role in any of my decisions. I'm just looking at this trinomial. The last sign is positive. So what does that say? If the last one's positive, Both signs match the middle term. So minus, minus. And I need an x and an x. Factors of 6, and they have to add up to be -5. So do you want 1 and 6 or 2 and 3? 2 and 3. That would give me an outer product of -3x and an inner product of -2x, which do add to be the -5x. And then if I wanted to check it the whole way, I would use the distributive property to see if I could get back to that. If you leave off the 5x, you've left off part of the factors. So you have to write all of it down. Is that okay? All right, let's skip to 13. I'm skipping around because although you need a lot of practice in Math Lab, I'm not going to do every one of them for examples. What if I have t squared minus 15t plus 15? In this one, there is no common factor. And I see a trinomial, so I go to trial and error. The last sign is positive, 2 minuses. And I know I need a t and a t. You are fast. Okay, the last number is 15, so I know that I need either 1 times 15 or 3 times 5, and they need to add up to be 15. And now everybody is joining you with the head nod, no, those won't work. There's no way to do that. It's a prime polynomial. I personally get a little uncertain sometimes when I'm working problems and I think, oh, that's got to be prime, because there's no way to check it. You're just exhausting possibilities and saying there's just no way to make it work. Okay, you feel like you can work with this. Don't forget, if you look in the notes that I'll print, I will have the sign patterns in there. I'm going to erase that thing. But I'm going to review them right now. If the last sign is positive, then both signs match the middle term. So let me do something in color. If the last sign is that, okay? If instead the last sign is negative, you always get a plus and a minus, a plus and a minus. Okay? All right. So we will stop lesson 6.2.